Hello friends, this is Gangadhar from the YouTube channel Maths Ganga. In this video, I am going to discuss the way of finding sum of factors for a given number. In the last videos, we discussed the way of listing the factors for a number and way of counting the number of factors for a number. Now here, way of finding the sum of factors for a number and a direct formula to calculate the sum of the factors of a given number. To calculate the number of factors or the sum of factors for a given number, initially we need to express the number as a product of primes. That means we need to do prime factorization for the number. For suppose I have a number, some n, and on prime factorization, the number is nothing but some 2 power 4 into 3 cube into 7 square. See, the prime factorization of the number n. And we know the way of listing the factors, the way of counting the number of factors as we discussed in the previous videos. Now here we are going to calculate the sum of the factors. So to calculate the sum of the factors, now I am going to list out certain factors. Okay, see how the factors are there for n. Every factor of n is a combination of the products of the powers of the primes 2, 3 and 7. Okay, see there are totally 4 plus 1, 5 into 3 plus 1, 4 into 2 plus 1, 3. That means there are totally 60 factors for the number n. We know the counting the sum of factors, the number of factors. There are totally 60 factors for the number n. If you write the prime factorization for each and every of those 60 factors, the prime factorization of a factor of a number n is a combination of powers of 2 up to 4, powers of 3 up to 3, powers of 7 up to 2. So if I am going to list out the factors may be some 1 into 1 into 1, or some 1 into 3 into 7, or some 2 square into 3 cube into 7, or some 2 square into 3 square into 7, okay, or somewhere some 2 cube into 3 into 7 square. Like this we can write 60 numbers. All those 60 are combinations of powers of 2 up to 4, powers of 3 up to 3, powers of 7 up to 2. Those 60 are the factors of n. Now I am going to calculate sum of all those 60 factors. See, sum of all those 60 factors is nothing but, okay, see now I am writing a product here, just observe it, 1 plus 2 square plus 2 cube plus 2 power 4 into, and the next expansion is 1 plus 3 square plus 3 cube into, and another expansion is 1 plus 7 square. Okay, with our basic algebraic knowledge and by using the distributive property, we are able to multiply these 3 expansions. If you multiply these 3 expansions, the result contains the totally, since the 5 and 4 and 3, 5 into 4 into 3, the result involves with totally 60 terms. Okay, see 1 into 1 is a term, 1 into 3 into 1 is another term, 1 into 3 into 7 is third term, 1 into 3 into 7 square, some 2 square into 3 square into 7. Like that, if you try to multiply these 3 expansions, in the result you will get totally 60 terms, sum of 60 terms. Now what I am going to tell you is each and every term of that expansion is nothing but a factor of n. These are the factors of n, and if you observe, you will get different terms in the product of these 3 expansions. Every term of this product resembles one factor of the number n. So calculating the sum of these 60 factors is nothing but calculating the sum of these 60 terms of the product, which is nothing but calculating the product of these 3 expansions. Okay, so the value of the product of these 3 expansions is nothing but the sum of the factors of the given number n. So calculation of the value of the product of these 3 expansions is enough to mention the sum of the factors and to calculate this value. This is 1 plus 2 square plus 2 cube plus 2 power 4. Okay, and we have a rule from the algebra that x power n minus 1 by x minus 1 is nothing but 1 plus x power n plus 1 minus 1 by x minus 1 is nothing but 1 plus x plus and so on, x square plus x cube plus and so on plus x power n. We have it from the algebra. Okay, x power n plus 1 minus 1 by x minus 1 is 1 plus x square plus and so on plus x power n. With this logic, this 1 plus 2 square plus 2 cube plus 2 power 4 is expressed as 2 power 5 minus 1 by 2 minus 1. And the second expansion 1 plus 3 square plus 3 cube is expressed as 3 power 4 minus 1 by 3 minus 1. And the next one is 7 power 3 minus 1 by 7 minus 1. And if you calculate, 32 minus 1 is 30 by 1 is 30. And here 3 power 4 is 81 minus 1 is 80 divided by 2 is 40 into 7 cube is 343 minus 1 is 342 divided by 6. 342 divided by 6 is nothing but 50. 6 plus 6 5 is 30 and 6 7 is 57. The product of these three values is nothing but the sum of the factors of the given number n. So to calculate the sum of the factors of the given number n, it is enough to calculate the value of the product of these three expansions. Value of the product of these three expansions is nothing but value of this product, and it directly gives the sum of the factors. So calculating sum of the factors is also an easy task. Okay, by calculating the product of these three expansions. Okay, if I generalize this way of calculating the sum of the factors of a number n. For example, if you have a number n, if I have a number n which is nothing but some p1 to the power alpha 1 plus, the prime factor is like this, p1 to the power alpha 1, p2 to the power alpha 2 and p3 to the power alpha 3 and so on, pn to the power alpha n. If this is n, this is the prime factorization of n. Okay, then sum of the factors is nothing but value of the product 1 plus p1 square plus and so on plus p1 to the power alpha 1 into, and related to this p2 power alpha 2, the second expansion is 1 plus p2 square plus and so on plus p2 to the power alpha 2 and so on. Related to some pn power alpha n, the expansion is 1 plus pn plus and so on plus pn to the power alpha n. The value of the product of these n expansions is nothing but represents the sum of the factors. See, if you multiply these products, these expansions, in the result we will get different terms. Each and every term will represent a factor of n. So sum of all the terms of this product is nothing but sum of the factors of n. So sum of the factors of n is nothing but value of the product of these expansions. So the value of this expansion is nothing but, as we mentioned in the above example, p1 to the power alpha 1 plus 1 minus 1 by p1 minus 1. And the value of the second expansion is nothing but p2 to the power alpha 2 plus 1 minus 1 by p2 minus 1. Like that, if you write, then the value of the last expansion is nothing but pn to the power alpha n plus 1 minus 1 by pn minus 1. If the prime factorization of the given number is like this, then sum of the factors of the given number n is mentioned by this formula. What is that one? Prime number to the power alpha 1 plus 1. Here we have alpha and this is alpha 1 plus 1 minus 1 by p1 minus 1, and that is the product. So directly we will use this one as a formula to calculate the sum of the factors. And the above example explains us the way of deriving this formula. Okay, so if the number is some 2 power 4 into 3 cube into 7 square, then by using this one, sum of the factors of the given number n is nothing but the prime number is 2 and alpha 1 is 4. So we will write that 2 power 4 plus 1 is 5 minus 1 by 2 minus 1. Already we did it. Okay, and for corresponds to 3 cube, 3 power 4 minus 1 by 3 minus 1. And corresponds to the 7 square, 7 power, the 2 plus 1 is 3 minus 1 by 7 minus 1. This product will give us the sum of the factors. This product will give us the sum of the factors. So for a number having this as prime factorization, sum of the factors of that number is this product. Okay, so sum of the factors we will calculate. In the same way, we may calculate the sum of the squares of the factors, sum of the cubes of the factors also. Okay, see, if anybody asks you to calculate the sum of the squares of the factors, that means we need to square each and every factor and then we need to add. So sum of the squares of the factors is nothing but product of the expansions. Okay, if anybody asks you to calculate sum of squares of factors, sum of squares of factors is nothing but value of the product of the expansion, like 1 plus p1 square plus p1 square whole square plus p1 cube whole square plus, okay, see, like that p1 plus p1 square plus p1 square whole square plus, like that we will get p1 square power alpha 1. Why? Because we are calculating the sum of the squares of the factors. To calculate the sum of the squares of the factors, we have to square each and every factor of n and then we need to add. Okay, see, if you square each and every factor of n and then if you add, the sum of all those squares of the factors is nothing but sum of the different terms involved in this expansion, like 1 plus p2 square plus p2 square whole square plus p2 square power alpha 2, like that 1 plus pn square plus and so on plus pn square power alpha n. And if you simplify, you will get that here p1 square is the common rising term. So p1 square power alpha 1 plus 1 by p1 square minus 1. And coming for the second expansion, p2 square power alpha 2 plus 1 by p2 square minus 1. And for the last term, pn square power alpha n plus 1 by pn square minus 1. This product will represent the sum of the squares of the factors of n. In the same way, we can calculate sum of the cubes of the factors of n, sum of fourth powers of the factors of n, like that. See, if this is the prime factorization of the given number n, we mentioned the sum of factors and we mentioned here the sum of the squares of the factors. And if anybody asks you to mention the sum of the kth powers of the factors, okay, like sum of squares of factors, sum of cubes of factors, sum of fourth powers of factors, like sum of kth powers of factors of given number n is calculated by using the logic that p1 power k to the power alpha 1 plus 1 minus 1 by p1 power k minus 1 into p2 power k to the power alpha 2 plus 1 divided by p2 power k minus 1 into, like that if you continue, pn power k to the power alpha n plus 1 minus 1 by pn power k minus 1. Okay, see, since we are calculating sum of kth powers of factors of the number n, we use this product as the formula to calculate. Okay, what is the word? p1 power k to the power alpha 1 plus 1. Since we are calculating sum of kth powers, we are using k here. Okay, and related to the power alpha 1, we mentioned here alpha 1 plus 1. And the value of this product is nothing but the sum of the kth powers of factors of the number n. So we use this for sum of kth powers and we use the previous one. By replacing k with 1, we will get the sum of the factors of n. Okay, sometimes they may ask you to calculate the sum of even factors of n, sum of odd factors of n, sum of the factors of 3 multiples, like that. See, if you ask like that, we use the traditional way what we discussed in the previous videos. Okay, for example, this is the sum of the factors. For this number, there are so many factors. Okay, see, for example, if anybody asks you to calculate the sum of the even factors, so sum of the even factors is nothing but, surely we need to select one number among this 1, 2, 2 square, 2 cube, 2 power 4. And this is 1, 3, 3 square, 3 cube, and here we have 1, 7, 7 square. For sum of the factors, sum of all these numbers plus into sum of all these numbers into sum of all these numbers will give us the sum of the factors of n, and that simplification leads to this product. Now if anybody asks you to calculate the sum of even factors, to calculate the sum of even factors, so there is no chance to select this one from this column. We need to select one number from this column, one number from this column, one number from this column to make a factor of n. Since we are calculating sum of even factors, we need to make even factors and then we need to add. To make an even factor, we have no chance to select this one. So leave that one. Select any one among these remaining 4 numbers. So sum of even factors is nothing but 2 plus 2 square plus 2 cube plus 2 power 4 into 1 plus 3 plus 3 square plus 3 cube into 1 plus 7 square. Okay, so see, this product will give us the sum of the even factors. Actual product is what? Actual product is 1 plus 2 square plus like this. But since you are calculating sum of even factors, you just remove this 1 and that product represents the sum of even factors. Okay, and this is the actual product. If anybody asks you to calculate the sum of the odd factors, what we do? Since we are calculating sum of odd factors, we have to neglect every power of 2. So remove all these 2's. Okay, then automatically 1 into this product will give us the sum of odd factors. Okay, there it is. Okay, since this is the actual product, if anybody asks you to calculate the sum of factors of multiples of 9, see, among all the factors of n, among the 60 factors of n, some factors are multiples of 9 and we need to add sum of all those factors which are multiples of 9. So to calculate the sum of the factors which are multiples of 9, we need at least 3 square. So we don't need this 1 and 3. So just remove this 1 and 3. Right? Only 3 square and 3 cube is the second expansion. See, the product of these 3 expansions will give us the sum of the factors of multiples of 9. Okay, see, this is the actual expansion, right? And if anybody asks you to calculate the sum of the factors which are multiples of some 21, since we are going to calculate the sum of the factors which are multiples of 21, the factor must involve with at least 1 3 and with at least 1 7. So you just neglect this 1 and this 1. Okay, then the product of these 3 expansions will give us the sum of the factors which are multiples of 21 for the given number n. Okay, if anybody asks you directly to calculate the sum of the factors, we have the formula. And if anybody asks you directly to calculate the sum of the kth powers of the factors of n, and we have a formula. And if the question is to calculate the sum of the factors which are odd, which are multiples of 3, which are multiples of 9, like that if they ask, depending on the question, we need to neglect certain terms of the actual product of the expansions, and then you will get the sum of factors of the required property. Okay, so this is the way of calculating the sum of the factors of the number n. Okay, see, if you practice with one or two examples, then it will raise your command on the concept. Okay, and I suggest you to practice certain problems regarding this, the sum of factors. Okay, and this is the video on the sum of the factors. Do subscribe for the channel. I hope this video is helpful for your preparation. If it is helpful for your preparation, do like it, share it, and refer it to your friends also. Thank you.